Okay, little algebra review. Now, if this first video is a struggle for you, it's not the end of the world, but this is a big red flag. This is these are the basics of just solving what we call like a linear equation, especially this first problem here. I'm not trying to scare you away, but there's a level of knowledge that's implied that we have. Now let's jump right into it. We're going to solve linear equations. That means that our x doesn't have a square, a cube. There's no square root on it. It's not in a denominator. So we know it's linear. Linear. And linear, think that it's because that thing's to the first power, really, is what's going on. Okay. Well, our game is we want to go solve for that x. We want to find its value. So let's go. Now, algebra works. This is just... It's like a little a balance beam, right? 7 weighs as much as 5x plus 3 does. And it's going to keep it balanced. Now, as long as we put the same amount of stuff on both sides, it's going to stay balanced. So the game will be, we want to balance the scale till we can get this darn x all by itself. So when you do algebra, it's kind of like the opposite of PEMDAS. You have 5x plus 3. What's the opposite of plus 3? Minus 3. So you write it on both sides. You got to balance the scale. Left with 5x is equal to, the 3 minus 3 goes away as desired. And then 7 minus 3, of course, is 4. Now we have 5 times x is equal to 4. What's the opposite of multiplying by 5? Dividing by 5. And now we get to here and we say that x is equal to 4 over 5. 4/5. Now, many of you get all excited and you want to punch that crap into a calculator and put it into something else. Don't you dare round any answers. For this, sure, if you wanted to write down 8/10 as a solution, that's fine. I don't know why you're doing extra work. I don't know why you would do that and have to punch it into a calculator to get that. But if you take one of these and you round it, when I ask for an exact, we malo. That'll be bad. You're going to lose some points. So just leave it. 4/5 is a good number. It's a good number. It's just a fraction. All right, you've seen a fraction before. How many years have you taken math classes that have had fractions in them? You going to get over it? You're going to finally figure it out, or are you just going to keep struggling on the same concept over and over that was introduced to you in 4th or 5th grade? I know, I fought it for years. Until one day I said, screw this, I'm just going to figure it out so I never have to struggle with it anymore. It's up to you. I'll get off my soapbox. All right, now we got kind of like a PEMDAS sort of thing going on here. It's still linear. Look, the x's, well, the first power. So the game is typically when you have all these parentheses, you're going to want to get rid of them. Get rid of them first. And then we'll combine like terms. We'll move stuff around like we did in the first one. And, hey, maybe we'll solve for x. So let's start off. On the left, we'll take that 7. We're going to distribute it into both pieces, the distributive property. So 7 times x is equal to 7x. And 7 times positive 1 is equal to 7. Now here, I'm going to have to do this one in 2 steps because I need to do what's inside of here first before I go trying to yank a 4 and bring it to everywhere, which is not the right direction where we shouldn't be going. So I'm going to leave this 4 on the outside. We're going to do it in 2 steps. Don't be afraid of writing too much. I'm more worried about y'all writing too little because I know I think students deal with carpal tunnel syndrome because they never seem to be able to want to write much. They're like, I can't write this over and over. It's too much. So negative times 3 is equal to negative 3. Negative times negative x is equal to positive x. There we go. Hey, why don't we go combine some like terms? We got an x and an x. So I think if you give me one x and then you give me another x, then there might be 2 of those frickin' x's, right? So working down. Looks like we're here. Please try and do your algebra working down. When I see left to right, that typically tells me there's somebody that's going to make a lot of freaking errors. Work down. The best way for it to go through to minimize if you could. Now let's get rid of this final bracket. And we'll distribute in that 4. So we have 7x plus 7 is equal to. So 4 times 2x is equal to 8x. 4 times negative 3 is equal to negative 12. Now we have 7x plus 7 is equal to 8x minus 12. Let's get our x's on one side, let's get our numbers on the other side, and then we're going to end up being able to find our solution. Now, I don't like moving the numbers first. I like moving the x's first so I can make sure we don't deal with a negative number on my x. Since 7x is smaller than 8x, I'm going to subtract 7x over. And what's going to be left? You're still going to have a 7 on the left-hand side, but 8x's minus 7x's will leave you with 1x. Minus 12. Now let's kick that 12 to the other side, and I believe we'll have ourselves a nice little answer telling us that 19 is equal to x. Beautiful. Algebra, huh? Beautiful thing about algebra is you can take your answers and you can plug them right back in for x and see if you're correct. If you're moving on to, say, a calculus class, that will no longer be the case. You might want to take advantage of stuff like this now. Trig and algebra, you can typically check your answers a little bit. Okay, and the last one for this video. Wow, where did I put it? Oh, there it is. There it is. Oh no, it's fractions. What do we do? Panic? Give up? Or start using the idea that, hey, okay, there's an equal sign. There's an equal sign right here, which means you can multiply this equation by whatever the heck you want to on both sides. So you could try and put your fractions together and all that, or you could just fraction bust and go, wait a second, there's a 6, a 3, and a 4. Why don't we come up with a least common, what do they call it, like the denominator or something like that? Or just multiply by the least common multiple. 6, 3, and 4. Like what number do they all go into evenly? Which number do they all go into evenly? It's 12, right? It's 12. Now, say you didn't know it was 12, because we're going to multiply both sides by 12. Just take 6 times 3 times 4. Put it all together. We're 72. They all go into 72 as well. That'll work. It's just not as efficient, so I'm going to use 12. So here it is. Just going to multiply both sides of this equation by 12. Comes in. It goes to all 3 terms. But careful, there's an implied parenthesis on top of this, and I see this with students that we typically don't like to write parentheses very much. So I'm going to put a parenthesis around that and then go, well, look, there's the 12. Because we don't really want the 12 to go with the x plus 3. We want the 12 and the 6 to play around with each other. Now we have our 2 over 3. Our 12 comes flying in, so it's times 12. And then plus, we have our last one. Get rid of this nonsense. We'll have this x minus 5. I'm going to put a parenthesis around it. There's always an implied parenthesis around every fraction. And we bring that 12 in. So really, all we did, let's look back, is whatever that least common denominator, we just placed a 12 next to all 3 pieces. Now let's clean it up. That's 2. That's 4. That's 3. Right? You know 12 divided by 4 is 3. You know 12 divided by 3 is 4. You know 12 divided by 6 is 2. So what's left over? Well, we got that 2 that we reduced down times x plus 3 is equal to, we got our 2 times our own, that became a 4. But the game is we got rid of fractions. Isn't that what you always want? Do you like problems that have fractions or not fractions? So learning these, when you have an equal sign, multiply both sides of the equation by something. So now we're going to remove, we're home free at this point. You know what I mean? We're just going to go through and we get what, 2x plus 6, distributing to both. 2 times 4 is equal to 8. 3 times x is equal to 3 times x, and 3 times negative 5 is equal to negative 15. We'll combine some like terms on the right-hand side. We got 3x. 8 minus 15, what is that? Negative 7. Now again, I'm going to move my x's first. And that's going to leave us with 6 is equal to x minus 7. Let's add our 7 over to the other side. Be done with it, and let's call x is equal to 13, right? There it is, huh? Little linear equations with a little bit of fractions. We'll be back. We'll do some quadratics. All right? See ya.